guys, I wanted to go over the Unit 8 review from Edgenuity just for those of you who needed a little extra help. Some of the problems on here are kind of tricky, so let's go ahead and do it. This first problem says, in quadrilateral QRST, RST measures 5x plus 15 degrees, and angle TQR measures 4x plus 3. Here we have a quadrilateral that is inscribed inside of a circle, so what we need to remember is that opposite angles are supplementary. So these two angles right here, they're not going to be congruent, but they will add to be 180. So I know that the measure of RST plus the measure of TQR is 180. And I can plug in the values I know, 5x plus 15 plus 4x plus 3 equals 180. All right, now combining like terms, 5x plus 4x gives me 9x, and 15 plus 3 gives me 18. All right, now subtracting 18 on both sides of the equation, I get 9x is equal to 162. All right, and we divide both sides by 9, and I get x is equal to 162 divided by 9 gives me 18. All right, we're not quite done yet. It asks, what is the measure of angle RST? So we're going to take this value of x and plug it in for 5x plus 15. So the measure of RST is equal to 5 times 18 plus 15. 5 times 18 is 90 plus 15 is 105 degrees. Okay, this next one says line EF is tangent to circle G at point A. If the measure of arc, or the measure of angle CAE is 95 degrees, what is the measure of arc CBA? Okay, this one works a lot like inscribed angles that we talk about. I know that the measure of angle CAE is going to be 1/2 of the measure of the intersected arc. So the intersected arc here is arc CBA. All right, so plug in what we know. I know that 95 degrees is going to be 1/2 of the intercepted arc measure. All right, multiply both sides by 2, so I can solve, and I get the measure of CBA is 190 degrees. All right, this next one says line segment ON is perpendicular to line segment ML, and PN is equal to 10. So there's some information to break down here. I notice that OM is 25, and that's a radius. So all the other radii will be congruent and be 25. So I know OL is 25 as well. Now, if you'll notice in this circle, this segment ON, when put all together, is a radius. So to find the length of OP right there, I need to subtract 10 from 25 and get 15 so that it adds up to be congruent to the other radii. Now we're also given that this is perpendicular, so we have a 90-degree angle right here, and it forms a right triangle. Now our ultimate goal is to find the area of this whole triangle right here, MOL. So I'm given the height, which is 15, or the altitude, and I need to solve for the length of the base, because the area of a triangle is 1/2 base times height. So to do that, we see that it is split between two right triangles, two congruent right triangles, so I need to solve for that bottom measure right here. 25 is going to be the hypotenuse, so I know that 25 squared is going to be equal to 15 squared plus PL squared. All right, 25 squared gives me 625. 15 squared is 225, and then PL squared. All right, subtracting on both sides, minus 225. I get that 400 is equal to PL squared. All right, now I want to take the square root of both sides to solve for the length of PL. And I get PL is equal to plus or minus 20. But here, since we're talking about the length of something or the radius, it's only going to be the positive case. So positive 20. Okay, now I have that length, and this length over here is also going to be 20. So the length of the whole base is going to be 40, and the height is 15. And I get the area of this circle is 1/2 times 40 times 15. 1/2 times 40 times 15 gives me 300. So 300 units squared. Okay, this next one says a circular tabletop has a radius of 24 inches. What is the area of the tabletop to the nearest square inch? Use 3.14 for pi. So the area of a circle is equal to pi r squared. And in this case, they tell us you use the decimal approximation 3.14. So in place of pi, I'm going to write that. And I know that the radius is 24 inches squared. 3.14 times 24 squared gives me 1,808.64. Now it's said to round to the nearest inch. So since this is 0.6, we're going to round up to 1809 inches squared. Okay, consider circle N with radius of 30 centimeters and theta is pi over 6 radians. What is the approximate length of minor arc LM? Round to the nearest tenth of a centimeter. Okay, so here you'll need to find the arc length. And to do that, since we are talking in radians, it's going to be your central angle over 2 pi times 2 pi r. This part theta over 2 pi gives us how much of the circle we're looking at respectively times the circumference 2 pi r. So here, I want to plug in pi over 6 divided by 2 pi, and then multiplied by 2 pi, and my radius is 30. Okay, pi over 6 divided by 2 pi, I can rewrite this as pi over 6 times 1 over 2 pi, and then multiplied to 2 pi times 30, which can simplify to 60 pi. All right, so here we will multiply the numerators together. Pi times 1 gives me pi, and then 6 times 2 pi gives me 12 pi. All right, numerator and denominator, those pi's will cancel out, and I get 1 over 12 times 60 pi. And that gives me 60 pi over 12, which simplifies to 5 pi. And we want an approximate length, so we'll go ahead and plug this into our calculator. 5 times pi gives me 15.707, or 15.7 centimeters. Okay. We have that circle, given circle O, and the A intercepts BC, and D intercepts BC. We want to prove that angle A is congruent to angle D. Two statements are missing reasons. What reason can be used to justify both statement 2 and 3? So let's just think through this for a second. I want to prove that angle A and angle D are congruent. And I know that's true because they share the same intercepted arc of BC. Now, this first statement says that arc intercepts BC and angle D also intercepts arc BC. And that's given. This next statement says the measure of angle A is equal to 1/2 the measure of arc BC. And I know that's true because angle A is an inscribed angle to arc BC. Same reason for step number 3. Angle D is an inscribed angle, and that's 1/2 the measure. So, to justify both of these, we can use the inscribed angles theorem. All right, points D, E, and F are on circle C, and EF is congruent to DF. So here, there's a few different ways to solve this. I'm going to go over what I think is the easier way. You'll notice that this quadrilateral that formed is a kite because I have these two congruent chords down here, DF and EF, and then these two tangents will also be congruent. So it forms a kite. And what I know about kites is that these angles opposite the congruent sides are going to be congruent to each other. So first thing I want to do is I want to solve for this angle F right here, okay? And angle G is a circumscribed angle. So I know that since it is circumscribed, the angle plus the central angle is going to be supplementary. So this 76 plus the measure of angle C, or DCE, is going to be 180 degrees. Subtracting 76 on both sides, I get that the measure of angle DCE is 104 degrees. Okay, so here I have 104 degrees. Now, you'll notice that this is a central angle. C is the center of the circle. And since it is a central angle, that means its intercepted arc, DE, is going to be congruent, the measure of it. That's also going to be 104 degrees. Okay, from here, we will find the measure of angle F. So angle DFE is an inscribed angle. And I know that the measure of the inscribed angles, DFE, is going to be 1/2 the measure of the intercepted arc. So 1/2 the measure of the arc, DE. Now I know what the measure of arc DE is. It's 104 degrees. So 1/2 of 104 gives me 52 degrees. So this angle down here is 52 degrees. Okay, we are well on our way. We're almost there. The last thing to notice is that these angles GDF and GEF are congruent, and the total measure of the interior angles of a quadrilateral are going to be 360 degrees. So setting up my equation to solve, I get that 76, and since I don't know what these two angles are, we'll just call them x. I know they're going to be the same. So plus x, and plus 52 is equal to 360. All right, we can combine like terms on the left side. 76 plus 52 gives me 128, and x plus x gives me 2x. All right, from here we will subtract 128 on both sides. And I get 2x is equal to 232. Dividing both sides by 2 to get x by itself, I get x is equal to 116 degrees. Okay, now what it's asking is it's asking for the measure of this angle CDF right here. So this small little angle. And I know that the whole measure of the angle is 116 degrees. So this is 90 degrees of it, that portion right here. So to solve for that little portion, we're going to take 116 minus 90, and that gives me 26 degrees. Okay, arc QVT measures 156 degrees. Which statement must be true? All right, so each one of these are talking about angles QRT and QST. So angle QRT is this one right here, and angle QST is this one right here. Now, you'll notice that they both intercept that same arc QVT. So I know that they're going to be congruent angles. They are also inscribed angles. So their measure is going to be 1/2 the measure of the intercepted arc. So the measure, if we solve for 1 of angle QRT, is going to be 1/2 the measure of arc QVT. And I know the measure of arc QVT, that is 156 degrees. So the measure of angle QRT is going to be 78 degrees. And since these both intercept the same arc, they're both going to measure 78 degrees. Okay. In the diagram of circle O, what is the measure of angle ABC? I like to think about this as ABC is a circumscribed angle. And here we have a central angle created by COA if we draw it in, and that measure is going to be 146 degrees. And I know that circumscribed angles and central angles are going to be supplementary to each other. So here we could call this angle X, and I know that X plus 146 is going to be equal to 180 degrees. Subtracting 146 on both sides, we get that X is equal to 34. So 34 degrees. Okay, the measure of the central angle XYZ is 3 pi over 4 radians. What is the area of the shaded sector? So here my central angle is 3 pi over 4. And to find the area of a shaded sector, and it's in radians, we will take 3 pi over 4, divide that by 2 pi, and we will multiply that to pi r squared. Now 3 pi over 4 divided by 2 pi can be written as 3 pi over 4 times 1 over 2 pi. And then I know that the radius is going to be 16, so pi times 16 squared. Now I can do some simplification. Multiplying together these numerators, 3 pi times 1 is 3 pi, and 4 times 2 pi is 8 pi. 16 squared is 256, and I still have that pi hanging out there. Okay, and in the numerator here we have a pi, and in the denominator we have a pi, so those are going to cancel each other out. And we get 3/8 times 256 pi. Now each of your answers are in terms of pi, so I would just go ahead and leave that alone when you plug it into the calculator. And we simplify, and we say 3/8 times 256 gives me 96 pi units squared. Okay, angle K measures 67 degrees and angle L measures 119 degrees. So here I have 119 and angle K is 67. And again, we have a quadrilateral that is inscribed inside of a circle. So I know that the opposite angles are going to be supplementary, which means that angle L plus angle N is 180 degrees, and angle K plus angle M is also 180 degrees. Okay, now we can set up to solve. So here angle L is 119, and then angle N, we are solving for that, is equal to 180. We subtract 119 on both sides, and I get angle N is equal to 61 degrees. Now solving for angle M, we can plug in the value of K, so 67 plus angle M is going to be 180. Subtracting 67 on both sides, we get that the measure of angle M is equal to 113 degrees. So our option here is the third one. Okay, now what is the radius of a circle whose equation is x minus 7 squared plus y minus 10 squared equals 4? If you'll recall, the standard form of an equation of a circle is x minus h squared plus y minus k squared, and that's going to be equal to r squared. All right, now hk is the center of the circle, and then r is the radius. So when I'm solving for the radius, we want to set r squared equal to 4. Okay, and then I'm going to take the square root of both sides, and I get r is equal to plus or minus 2. Now, since we're talking about a radius, this is a measure of length, and you can't have negative length. So it's just going to be positive 2 units. Okay, now from here, it says, what is the radius of a circle whose equation is x squared plus y squared plus 8x minus 6y equals, or plus 21 equals 0. So what you'll need to do here is you will need to use a process called completing the square. I have this general form equation that I want it to look like, x minus h squared plus y minus k squared equals r squared. So first thing I'm going to do is I'm going to move the constant to the other side. So, and I'm going to group together my x terms and my y terms. So first thing I'll do is subtract 21, and I get x squared plus y squared plus 8x minus 6y is equal to negative 21. Okay, now we're going to group together our x terms, x squared plus 8x, and I'm going to leave some space here, and we'll group together our y squared, or y terms, y squared minus 6y equals negative 21. Now what I'm hoping to achieve is I'm hoping to create something that allows me to factor this expression so that it looks like x minus h squared. In other words, I want to create a perfect square trinomial by completing the square on both x and y. That's why I've left a little bit of space right here. So if you guys will recall, completing the square from Algebra 1, what we need to do is we need to add something to both sides of the equation so that it creates a perfect square trinomial, or 2 being multiplied together. Because remember, x minus h squared is the same thing as x minus h times x minus h. And the way that factoring works is I know that here, since the coefficient is 1, I know I'm just going to have x and x. And what I need is I need a number that will add to be 8x and multiply to be whatever number this is here. And since it's going to be perfect square, I know it has to be the same. So the numbers that add to be 8 that are the same are positive 4. And then positive 4 times positive 4 is 16. Okay, and then that means that I can create x plus 4 squared. And then on this y squared, we're going to do the same process. So I want to add the perfect number so that I can create the perfect square trinomial. So y squared minus 6y, I need to find a number that adds to be negative 6y. So negative 6y, two numbers that are the same that add to be, that is negative 3. And then negative 3 times negative 3 is positive 9. So that's going to be the perfect number that I add to both sides. And when I do that, I get x plus 4 squared times y minus 3 squared is equal to, and then negative 21 plus 16 is negative 5, and negative 5 plus 9 is 4. Now I have something that mirrors this standard form equation. So what I can do is on this right side is going to be my radius, and I know that r squared is going to be 4. So again, we take the square root of both sides, and I get that the radius is equal to 2. All right. This next one says, what is the measure of angle ADM? And we're given some information up here, so I'm going to move this out of the way really quick. It says points A, B, C, D lie on circle M. Line segment BD is a diameter, and the measure of arc CD equals the measure of arc DA. Okay? So, what you'll notice too, in the picture, there's drawn a right angle right here, and its intercepted arc is CA right here. So a right angle has a measure of 90 degrees. And these two are equal, so I divide 90 by 2, and I get each of these is equal to 45 degrees. And if you'll notice, the angle that we are solving for, angle ADM, right here, is an inscribed angle to this arc of 45 degrees. So the measure of angle ADM is going to be equal to 1/2 the measure of arc BA. I know the measure of arc BA is 45 degrees. So I get 1/2 of 45, which gives me 22.5 degrees. Now, this is by no means the only way that you can solve it, but it is one way. Okay, Liliana is making a vase with a circular base. She wants the area of the base to be between 135 centimeters and 155 centimeters squared. Which circle could represent the base of the vase? We want to use 3.14 for pi. So remember, the area of a circle is equal to pi r squared. And in this case, we're just using the decimal approximation, 3.14. So for each of these, what I can do is I can plug in the radius, and I get 3.14 times 6 squared, and that gives me 36 times 3.14. Let's go ahead and check what that gives me. 36 times 3.14 is 113.04. All right, that's not quite the specification she wants, so let's go ahead and check the next one. I have 3.14 times 7 squared, or 49 times 3.14. 49 times 3.14 is equal to 153.86. And that falls right in the category. So the second circle right here is going to be an option. All right, that is the last problem that is on the review. Please let me know if you guys have any questions or if you see something on Ingenuity that you're like, I'm not sure how to do this. I would be happy to help. You can send me screenshots or just message me in WebEx, and I'm here to help. Hope this was helpful.